You haven't learned trig at all ever in your life, right? We've got our kind of memory tool, SOHCAHTOA, where the S is sine, the C is cosine, and the T is tangent. That X is your angle, right? So if I'm given an angle and a side, I should be able to find the other sides. Step number 1 is to label them opposite, adjacent, and hypotenuse. So opposite the angle you're given, that's the O. Hypotenuse is always opposite the right angle. And then the X, in this case, is the adjacent. How's everybody feeling about just doing the O, the A, and the H? Does that make sense to everybody? Because I know this is brand new. Make sense? So once you have that, you need to look for what you want. In this case, I'm asking for the X, and look for what you have. So we're going to cross out the H. I don't have any information about the H, and honestly, in this problem, I don't really care about the H. Which of our 3 functions over here relates O and A? Tangent. So now we're just going to fill everything in. Tangent of my angle. So I know that says X, but that's really the angle. So that's 39. Equals, and then we make a fraction, O over H. So 11 over X. Everybody good with substituting that stuff in? So the X is always the angle, or in this case, the angle always goes next to the sine, the cosine, or the tangent. The angle always goes right there. And then you just substitute in your O and your A and your H, depending on what the fraction is. And you just have to memorize these 3 things. Those never change. Always sine, cosine, tangent of the angle, and then equals some kind of fraction with some combination of O, A, and H. So, Mikhail, this is what you missed yesterday. When I have an X in the denominator here, what do I have to do with those 2 things? Anybody remember from yesterday? What do I have to do with them? I got to switch them. So X is going to equal 11 divided by tangent of 39. Okay. And again, all we're doing is using the angle and the 11 in order to find that bottom, that horizontal distance. So then I can go over and open up Desmos. And I forget what it was. 11 divided by tangent of 39. 11 divided by, and then I can go down here to my keypad and functions and get tangent. Can you guys see my Desmos calculator? Yeah? Okay. And then 39. Why didn't I get 13.5? What did I forget to do? I did not change it to degrees. You are 100% correct. So 13.58. So over here, X is 13.58 or 13.6. So let's try number 9, since that's sitting right here, easy for us to see. Label it O, A, and H if you can. And I know it takes a little while because I have it on Google Slides, not the Pear Deck. Is the 8 the O, the A, or the H? So I would like you to do them, yeah. Because I want to do these together to make kind of as a review to make sure everybody is on the same page because it's such a brand new stuff. Unless you guys think you know it well enough, and then I can let you go in your breakout rooms and do them together. I can give you the choice. What would you rather do? Do these together or do them in breakout rooms? Okay. So the 8 is going to be the O, the A, or the H. Oh, yeah. So the 8 is the opposite. That's the O. What's the X? The A or the H? The A. That's the adjacent side because the hypotenuse is over here. So what function am I going to use? Sine, cosine, or tangent if I have the A, or I want the A and I have the O? Tangent. So tangent of my angle. And then again, my formula is the same. It's O over H, or O over A. Oh, darn it. This one's exactly the same. Just like William said before, what do I have to do with the X and the tangent 51? Flip them. And then you go to Desmos and put that in Desmos, or use your calculator. Your phone calculator has this too. You just have to hold it horizontally instead. That's what I got. 6.48. And that kind of makes sense because this is going to be a smaller angle. So I should predict that it's going to be smaller than 8. 6.48 or 6.5. Let's do all 8 of these together just to make sure everybody's good. So you can definitely work ahead if you want. What would I do for number 8? How would I set it up? What do I need to mark? Where's the O? Where's the A? Where's the H? So I've got O over here, got A here, and I've got H here. So I'm not going to use the O. So I'm going to use cosine. Cosine of 46 equals the A first over the H. So cosine of my angle equals A over H. And you just have to memorize those 3 functions, right? Because I've got a number down here, it's kind of like we're just doing a proportion. We're just going to cross multiply here. So there's no need to flip it because my X is in the denominator. That's why I flip. Here, my X is in the numerator. So I just multiply. So X equals 28 times cosine of 46. And what do you get when you do that multiplication? Should be something less than 28 because 28 is the hypotenuse. It's always the longest side. And kind of always think about the reasonableness of it. What about 10? Is that going to be so, ka, or toa? It is going to be sine because we've got the opposite side and the hypotenuse side. So O and H go with sine. So sine of 24 equals O over H, so X over 31. And then do I divide those or do I multiply them? How do I solve that equation? Multiply, for sure. If x is in the numerator, you're going to multiply. So x equals 31 times sine of 24. Is it going to be smaller than 31 or bigger than 31? Mm-hmm. Boom. Ah, not 061, just 61. I gotcha. Like that? How are we feeling about these? We okay with them? Starting to be? I always feel very gratified when we start getting good at trig. So while everybody wraps that up, I do want to go on to the next one. So the next slide, slide 3, is like what we did last week. This is finding the angles. So here, let me zoom in a little bit. We've got those, oh, hello. There we go. We've got the same, there we go. We've got the same equation. We've just got the angle in a different spot, right? So here we're looking for degrees. We're looking for an angle. So I just kind of remember that -1 is my degree symbol. This is when I'm looking for an angle. Okay, I'm looking for that angle. Oops. Boom, boom. We're looking for the angle. So it's a little bit easier. We don't have to worry about multiplying or dividing or whatever. We just put it in exactly the way we see it. Still have to do the opposite, the adjacent, and the hypotenuse. So in example number 1, what am I given? What are the 24 and the 15? Opposite, for sure, and hypotenuse, absolutely. And so what function do I need to use? Sine, cosine, or tangent? Mm-hmm. And remember that x is my angle that I'm looking for. So sine, I'm looking for an angle, so I need that -1. It's called inverse. And then O over H, so 15 over 24. And then we just put that into the calculator. So if I'm in my Desmo, instead of having the sine, cosine, tangent, we're going to do inverse sine. So I need that little -1. And then I forget what it was, 24 over 15 or 15 over 24. 15 over 24. The order really matters. 15 over 24. Remember, you still need to be in degrees. And then boom. 38.68. So try number 2 or number 3 and see what you get. It's not. So the hypotenuse is always the big. So if you have sine and cosine, the biggest is always at the bottom. But with opposite and adjacent, like we have here, opposite side and adjacent side. And that's the tricky part. The opposite is usually pretty easy to see, and the hypotenuse is easy to see. Then the adjacent is the other one. So I'm not going to use hypotenuse. So I'm going to use tangent. Tangent, I'm looking for the angle, so I use the -1 and then O over A. So in this one, it is going to be small over big. But if I was going from the other angle, then it wouldn't be small over big. And hopefully we have an example where it's not. And I haven't opened the Pear Deck. That's why we're working on the Google Slides. Even though I know I have Pear Deck underneath, I think I'd rather you guys do this in Google Slides today. And I know it's tougher to write. I'm sorry about that. So what did you get for your angle? I got 32.7 for the first one. What'd you get for number 3? 28.4? So I got 28.4 for number 3. It should be 20 over 37. Because it's O over A. Maybe I did something crazy. $28.39. Okay. We're on the same page then. Let's do number 2. So do I use sine, cosine, or tangent for number 2? I think it is cosine. So that's the opposite side, and I don't have any information there, so I'm not going to use it. So I'm going to use cosine because ca is cosine of my angle equals A over H. Because I don't have an angle, I'm going to do cosine inverse or inverse cosine, and then 8 over 11. And that A is always the one that messes people up. That's why we're practicing together. So cosine -1, 8 over 11. So if I put inverse cosine 8 over 11 in my calculator, oh, it didn't like that. Oh, because I did something weird. 43.3, is that what you got, Mikhail? 43.3? And then what about number 4? Is that going to be sine, cosine, or tangent? So I've got O is the opposite, H is the 23, and adjacent. So we're going to do A and H, so that is cosine. I'm looking for an angle, so I got to do inverse. And then A over H, because so ca toa, A over H, so 18 over 23. So inverse cosine 18 over 23 gives me how many degrees if I round to the nearest tenth? And these are all degrees. Nice. Super important to mark all those O, A, and H's. And we will continue to practice this for probably another week. So know that it's new. If you're still confused by it, it's normal. It takes a lot of people a long time to get the patterns of trig straight. But once you have them, they're really, really useful. So remember slide 2, if you're given a side and an angle, you can use these to find the other sides. If you're given 2 sides, you can use the inverse to find the angle. Once you have the angle, you can find everything, right? So if you have a right triangle and you're given 2 pieces of information, you can find all of the other pieces of information you need. Now that we've done that review, what I'm going to do is I'm going to send you through these slides. You're given the 2 legs of every triangle. So the process of solving these is going to be very similar as you go through. And I just want you to fill in the chart over here. So you don't have to do any work really on the slide. You just need to fill in the chart, but make sure that you're doing work and you're not just, letting somebody else carry the load. Okay. Questions on any of those? Call me into your breakout rooms. If it looks like it's not a right triangle, look for a little angle in the corner. For this one, angle A is the right angle. Right? So this is a swimming pool, but because of the perspective, like we did those perspective drawings, it doesn't look like a right angle, but that is the corner where the pool sides come together, right? The diagonal is BC. Okay. I can, yeah. So who do we want to be where? Yeah, absolutely. Let me go back. Okay. So what can I fill in my table? What do I know? I know AB. What's AB? 90. And what else do I know? Did somebody say BC? My chat went away. So let me open the chat. I don't know where the chat went. It's invisible. Okay, we just don't have the chat. Okay, so CB is what? What's CB? Also 90 feet. Sorry, I didn't hear. So how do I find AC? If they were angles, you could 100% do that. And the 90-degree angle, so what else is 90 degrees? Because there are a lot of 90s in a baseball field. What angle is 90 degrees? That angle B. But if I'm given 2 sides, this is like a throwback to the very first thing we did in this unit. If I'm given 2 sides of a right triangle, how do I find the hypotenuse? Starts with a P and is Greek. Pythagorean theorem. What is Pythagorean theorem? Boom. And are my 90s the A, the B, or the C? The A and the B, right? Because the C is the longest side. So we're going to do 90 squared plus 90 squared equals C squared. So what do you get for C once you do all that? 147? 127. And that's feet, right? So 127 feet. Okay. And then how do I find the angles? We could do 180 minus 90. So the whole triangle is 180. And I know B is 90. So we can definitely do that. So angle A and angle C are going to equal 90 degrees together. So how do I find out what each of them are? You can, because the two sides are equal, these two angles are also going to be equal, right? So if I divide by 2, what do I get for angle A and angle C? 45. Because a baseball diamond is a square, right? So it's two isosceles triangles. Just because we can, let's look and see how number 5 is different. So let's do this one together too. What can I fill in? And then I'll put you in breakout rooms. A to C is 30. What else can I fill in? B to C is 60. What else can I fill in? The 90 degrees. And which angle is that? Now what? We could do 180 minus 90. So 180 minus 90 is going to mean angle A plus angle B equals 90 degrees. We can do Pythagorean theorem. What do I put into the Pythagorean theorem? And what's my A value? What's my B value? What's my C value? So 30 squared plus 60 squared equals C squared, right? What is it? AB is 67. So that side AB is 67 feet. So how do I find A and B? Angles A and B. In the last one, we had an isosceles triangle, so we just divided by 2. Here, is that going to work? So if I have two sides, how do I find an angle? We just practiced it on slide 3. If I have two sides, how do I find the angle? Let's make B the x. Can I use inverse trig? Which two sides do you want to use? Because we have 3. We just need 2 of them. You want to do cosine? So cosine would be adjacent and hypotenuse. So inverse cosine is going to be 60 over 67. Can somebody confirm that? What do we get? We get 26.4. That's what I got. Okay. So B is 26.4 degrees. So how do I find A now? Subtract from 180. So what do I subtract from 180? The 26.4. My handwriting is hard to read. So what do you get? 63.6. Does that make sense? So you're definitely going to have to use Pythagorean theorem at some point. You're definitely going to have to use some kind of trig at some point, and you can choose which function you use because you're given 3 sides. And then you're definitely going to have to use triangle sum at some point. So each of these problems, in order to find different pieces of them, you're going to have to use 3 different things. You can't, so in an equilateral triangle, here, let me insert a slide real fast. Why can I not insert a slide? There's a slide. So the question was, if I have an equilateral triangle, right? 1, 2, 3. What are the angle measures of an equilateral triangle? 60. And what kind of triangles work with trig? It has to be what kind of triangle to work with trig? A right triangle. So can I use trig with equilateral triangles? You cannot. The only way, and there is an exception, and Michaela, I'm glad that you asked. Every year somebody asks. If you divide an equilateral triangle in half, it looks exactly like our basketball court over there. You've got a 30-degree angle and a 60-degree angle, and then you have a right triangle. So if you have an equilateral triangle, you can divide it in half, and we'll do that tomorrow. And then you can do some right triangle trig with it and then put it back together in an equilateral triangle. Yeah. It would, but is that an equilateral triangle? You're looking at the gymnastics floor, right? So a gymnastics floor has right angles. So over here at angle B, there is a right angle. Every single one of these has right angles in it. So the trick is to find out which one. So that is definitely 90 degrees at B. Okay. We ready to go to breakout rooms? You guys can work on it together for about 30 minutes. Okay. Do you want me to randomly assign or do you want to choose? Where'd my breakout rooms go? Oh, it was hiding. Okay. Amin, Mikhail, Jaquan, you guys want to be a group? Okay, your breakout room 1. And Daniel, Robert, Caitlin, you guys want to be a group? Okay. And then usually we've got Lovely, Justin, and Rory. Do I have that right? And I've got Faith and Esther. Braylon, do you and Lee and Kevin and Liam want to be a group? And then I have a lot of people in this last group. Boom. Let's give it 30 minutes. Boom. Hey guys, how are you feeling about this? You got it down now? Good. So do you still need me? Okay. Call me in if you do, okay, guys? I mean, if you have any questions, just call me in.
Do you take your food out of the microwave?
Hi, guys. How are we doing?
Hi.
Daniel, it sounds like you have a house full this morning.
Yeah. I didn't have my hair. That's great.
Yeah.
I can take the floor out.
So how are we feeling about Trig, guys? Getting better? Getting easier? Okay. If you guys want to share one document, you can do that. If you want to each do a slide or two and then compare notes on it, you can do that. However you guys want to structure it, okay? Let me know if you run across any problems. Okay. Jaquan, are you going to join your group? Jaquan, are you going to join Mikhail and Amin? Or are you working on your own today? Are you awake? Okay, let me know. I think Rory's coming back in. She must have gotten kicked out. How are you guys feeling about Trig?
It's good, but it's painful.
It's a lot to kind of get your hands on for sure. If you guys want to share one set of slides, you're welcome to do that. If you want to continue working on your own, you're welcome to do that too. So just kind of figure out how you want to do it once Rory comes back in. I'm going to leave so I can see where she went because I know I just put her back in here, but is her internet unstable?
I'm not sure. She just texted me and said that she doesn't know why she just got kicked out.
Oh, great. Okay. I'll go check on her and see where she is. There you are.
I got logged out. I don't really know what I did.
Yeah, I don't know that you did anything. I'm waiting for you to repopulate here because maybe I need to. I need to move you to a different breakout room and then move you back into 3. So I'm going to move you into 6 and then I'm going to move you back into 3. Okay.
Okay.
Okay. Hey, ladies, how is Trig? How are we feeling about it?
We're doing good. My microphone is like broken, so I'm FaceTiming Esther to hear you.
Okay. I saw that in the chat and I thought they are so resourceful.
Yeah, I have to do this for all my classes.
Has anybody put in a service desk ticket for you to try to get a different Chromebook? Okay, I can put in a service desk ticket for you. I'll do that right now. Can you do me a favor and look at the back of your Chromebook in really teeny tiny, like 2-point font? It'll say either like G3, G5, G7. Can you just tell me what G you have on the back of your Chromebook? Yeah, it's on the bottom. It should be in like on a silver sticker, maybe. And if you could tell me, like, there's probably a 8-digit number. I need that too. Do you see where it says it should be an odd number, like G3, G5, G7? It's okay if you can't find it. G7? Okay. And then do you have a white sticker with like maybe 8 or 10 numbers on it? Yeah, they're usually white. And it's okay if you don't have that either. Mm-hmm. Yeah. 596. All right, I'll put that service desk ticket into you. So you can talk through the mic, but you can't hear through the like audio speakers. Okay, cool. I'm going to leave you guys to that then. Sorry for the distraction, but we want to get your technology working. Okay. Hey guys, how are we feeling about Trig? Decent?
There's some parts that I'm having a little trouble wrapping my head around.
Okay. Like anything in specific? Anything I can help you with right now? What slide are you guys working on?
Right now, I'm on slide 6.
Okay. Do you want to share your screen so I can see it, or you want me to share mine? Yeah, absolutely. So you're on the gymnastics floor, right?
Yeah.
Can you see mine?
Yeah.
So what have you gotten so far?